Howdy, IB. It's Miss Kosh. There was a question on these two different problems, and I just made two lovely videos, and then discovered that my microphone was turned off. So here we go. Let's see if I can be clear. Okay, so the first one, how many four-digit numbers can be constructed in which the digits are in ascending order from left to right? Okay, so in this one, we think that order matters. Well, it does and it doesn't, actually. So what happens on this one is that the order is already predetermined for you. So like if I picked the numbers 1, 2, 3, 4, the only way that I can arrange them is in that order, 1, 2, 3, 4. So it's not that the order doesn't matter, it's that by telling us that they have to be in ascending order, that that there's, once you pick those four numbers, you have one particular way that you can arrange them, and that's it. So it says you cannot start with the number 0, and since this can't be 0, that means the smallest that this can be is 1. Well, everything else has to get bigger than that, which tells you that you can never use 0. Okay, so in the digits, when you have 1, 2, 3, 4, 5, 6, 7, my spacing, I don't know what to tell you, we have now thrown this one out. Okay, so we've got 9 other choices, and we want to pick 4 of them, and we're using a combination where order doesn't matter. Order does matter, but order is already decided for you, and there's only one way to order the 4 numbers. And that's why it's 9 choose 4, or 126. Okay, the next one, they talk about we have the set of tiles, this game that we can play. And so they say, explain why the total to be selected, the total number of orders in which the tiles can be selected is 4 factorial divided by, I lied, 144 factorial divided by 4 factorial raised to the 34th power. Oh, yeah. Okay, so the 44, I understood where that came from pretty quickly because we have 108 tiles here. So it's 4 times 9 times 3 gave us 108. We have 4 of those 3 dragons is 12. 4 of each of the 4 winds gives me 16. And we have 1 of each of the 4 birds in 2 different colors, and that gives me 8. So I understood where the 144 came from. I was feeling pretty good about that. So what I did at that point is that I scaled down to try and see what was happening. So I said, well, what happens if I have 3 tiles that all say A and 1 tile that says B? Okay, technically I have 4 factorial ways that I can arrange them. I have 4 choices for the first spot and 4 and 3 and then 2 and then 1. However, it looks the same if I pick A, if I pick this A versus if I pick that A, okay, or even the third A. Those would all, I draw those tiles and it doesn't look any different to me. So what happens, what does look different is where B falls, okay? And so I have, what I've got here is I've got 3 factorial ways to arrange these A's right in here. And so that's why we say 4 factorial for the total number of tiles divided by 3 factorial because this thing has been repeated. Those 3 are, I have 3 factorial ways to arrange them, but where they don't look any different, okay? That was a colorful mess, but hopefully that made sense. So back up here, we have 144 tiles in total, okay, 144 factorial. However, it will start to look the same. I've got, in this one, I have 9 tiles in each of 3 suits. So there's 27 things that happen. It's 4 of those 27. So when you pick one from this scenario right here, you will have 27 different images on those 108 tiles. Okay, and then we have, so it's 27 here, and then you've got 4 of 3 dragons. So you've got 12 tiles that have a total of 3 images. You have 4 of 4 winds, so you've got 4 images. And this one, all of these images are different. Okay, so that doesn't get taken into consideration. But when I have 27 plus 3 plus 4, that's equal to 34. So there were 4 in each of those, right here also. That's 4 factorial that we then raised to the 34th power because we could divide that we have each of those things that can be arranged 4 factorial ways. So hopefully that makes sense. Let me know if you have questions. Go practice.